So today will be primarily about Hadoop and R, and why. More than the introduction, I would like to discuss why they became so famous all of a sudden. Okay, and also we'll talk about R and Hadoop integration at very high level. Of course, we will have a separate class on doing that. So Hadoop is essentially a framework or an ecosystem for doing distributed data processing. Okay, it's run on top of a cluster, and cluster consists of multiple machines connected through an internetwork like Ethernet or InfiniBand or any other network. And your data is distributed across these different machines. And Hadoop is a framework that kind of manages that data distribution, as well as gives you a programming model through which you can interact with those data sets. Okay, and this is an open source project which is part of Apache Foundation. So you can download, anybody can download the data, download the code repository and work with it, and you can even contribute to the Apache Foundation. Okay, and it all started from a paper, research paper that was published by Google on a programming paradigm called MapReduce. The programming paradigm of MapReduce is not new. It was there well before Google published that paper. It's just that Google kind of showed a very good use case of that particular programming model in solving a real world problem. Okay, which dealt with lots and lots of data, not surprisingly, because it's Google, right? So that kind of opened eyes, if you will. In basically, people stood up and made notice of that particular paper. Oh, okay, this is a way we can analyze big data sets or large data sets, and that problem is kind of relevant to every industry, and therefore the entire MapReduce became so famous, and the open source initiative of Hadoop, which is primarily fueled by Yahoo, kind of resulted in what we have as Hadoop today. Okay, so it's open source, and therefore there are many distribution companies like Cloudera, Hortonworks. Actually, there are many other companies have their own distributions of Hadoop, like IBM, Oracle, and of course Cloudera and Hortonworks also have their own distributions of Hadoop. Okay, and the key characteristics of Hadoop is one, it is scalable. That means it's scalable to large data sets and large clusters of machines, and it is reliable. That is a very, very important aspect of Hadoop, is the reliability. Meaning, so the Hadoop clusters are typically built using commodity machines, not some enterprise scale high-end machines, but instead with commodity machines. Okay, so we would be using something like our desktop or a laptop in this particular cluster. Okay, and obviously these are not meant for doing some high-scale processing, and therefore they tend to crash, right? Sometimes your memory may get burnt out, your disk may go bad, or your communication network, or meaning your Ethernet card may get conked off, or your machine itself might become highly heated because you are doing lots and lots of processing and stuff like that. There are many ways in which a particular system can crash, right? So even in the presence of those failures, the Hadoop ecosystem or the Hadoop framework is able to operate on that entire data without any loss of information. Okay, that's the reliability aspect, and that is very, very important, and it's also called as fault tolerance. That is a primary key differentiating aspect of Hadoop when compared to all the previously existing data processing architectures. Okay, so fault tolerance is very, very important, and it's economical because the clusters are built using these commodity machines as opposed to enterprise machines. For example, if you take IBM mainframe computer, for example, it costs millions of dollars, and you can't build a Hadoop cluster using those high-end machines. Okay, instead you build using smaller commodity machines, and therefore it's economical. And also it's robust, which is kind of related to reliability and fault tolerance, and it's flexible because the programming model itself is simple enough to build whatever you want on top of it. Okay, so these are the key characteristics of Hadoop. Any questions here? Okay, no questions at all? Okay, good. What is Hadoop cluster? So Hadoop cluster is essentially a cluster in which Hadoop is installed, that's all. And the cluster is essentially a bunch of machines connected by a network. Does that make sense, Saronan? Okay. So yeah, Hadoop cluster is essentially a cluster in which Hadoop is installed. Any other questions? Okay, so yeah, we don't need to go into the core components as of now. This is going a bit into the architecture, but the primary thing I would like to kind of mention in this particular slide is the two aspects of the core Hadoop. One is the HDFS cluster, which is on the bottom. So HDFS is Hadoop Distributed File System, HDFS. Okay, and that is the component which is responsible for storing your datasets. Okay, so HDFS is for the storage aspect, and the MapReduce engine, which is a data processing platform, or the data processing platform, or the programming model that Hadoop exposes. So this one is related to how you process the data, how you analyze the data, how you access the data. Okay, so HDFS is for storing the data, and MapReduce is for processing and analyzing the data. Okay, so that's the only key aspect that I would like to kind of mention in this particular slide. And we will look at the exact architecture later very briefly. But if you're interested, you should look at those background materials like the Hadoop Essentials for Data Science. That will go in detail what this architecture is and why it is used in order to analyze large amounts of data. Okay. So, question. Hadoop is a framework that allows for the distributed processing of small datasets or large datasets. It's a pretty simple question. Obviously, large datasets, right? If it is small, why do I want to do distributed processing? It doesn't make sense. So, Hadoop is primarily devised for large datasets, but that doesn't mean that you cannot do small datasets as well. But it's primarily for large datasets. Okay, yeah, this is the Hadoop Essentials. You should go through them, at least the architecture part, if you want to understand what Hadoop is. Okay. So that's the very, very brief introduction about Hadoop. And next is R. Okay. If you're already familiar with any other analytics component like SAS and stuff, probably you know what R is, at least in terms of its capabilities. But if you're completely new, R is essentially a software for doing statistical computation as well as visualizations. Okay, so it has a graphics component as well to do the necessary visualizations, like plotting a bar chart or drawing a curve or plotting a histogram or something like that. Okay, and it is also open source, just like Hadoop. R is also open source. Anybody can download on your laptop, on your desktop. You can install, whether it's Windows or Mac or Linux, doesn't matter. R is available on all of those platforms, and yeah, you can install it and start playing with it. Okay, and it has become highly popular these days, primarily because it's open source. Okay, because it's free, and also because it is there for many years. Okay, it's at least a couple of decades since R is there in the market, and therefore it's a very, very mature product. Okay, and that's why all these big companies like Oracle, IBM, HP, EMC, all these companies are trying to kind of integrate with R. Okay, like Oracle has their own data analytic platform around Hadoop or database or anything. They want to integrate this data processing platform with R. Okay, they want to kind of enable data scientists work on these big data sets through R by integrating with their own solution. Okay, and that's the primary reason why R has gained so much traction in last 1 or 2 years. Okay, because it's open source and because all these companies have a platform to like process the big data. That means they can store and they can do some processing, but they don't have any tools for doing machine learning or statistical analysis on big data. Okay, the only thing that they have is this publicly available R or proprietary softwares like MATLAB and SAS. Okay, obviously integrating with those will be much more difficult and takes a lot of time, right? If Oracle wants to integrate with SAS, then they have to strike a deal, they have to work out the details and stuff like that. Okay, but integrating R and Hadoop or R and Hadoop based solution within Oracle, it's very easy. Everything is open source and probably readily applicable for all the customers as well. Okay, and that's the reason why R has become so famous, and it's important for you to learn R before you enter data science field. Okay, and that's primary reason why we in Edureka kind of emphasize on learning R, and therefore we spend significant amount of time in this particular course using R and working with R. Okay, in fact, tomorrow's class will be completely about working in R. Essentially, what are the basics that you would require in order to program in R language. Okay, we are going to learn that in tomorrow's class. Okay, so as I said, R is open source and free, and one important aspect of R is the packaging. Okay, so it's open source, so anybody can contribute it, but the way you contribute to R is through through packages. Okay, so each of this package is essentially like a package of routines that are used for a specific purposes. Okay, so if I am, for example, working on biological data, Okay, I may have certain statistical methods or certain hypothesis tests that are more relevant in this biological data analysis. Okay, so as a biologist or biological data analyst, I take all these methods and wrap them into a package, and then contribute that package to our community. Okay, so later on, if somebody comes in and they want to do some biological data analysis, then they can use the package that I deliver and get all the statistical tests and methods that I implemented already. They can quickly use them. Okay, so you are communicating or sharing these methods through packages. And similarly, there might be some packages for doing financial data analysis. And there might be some packages for doing classification, clustering. So it's not just about the domain, but also the individual techniques. Okay, we will learn about different packages as we go through different techniques later in the classes. But the only thing that I want you to understand at this point in time is that the extensibility, meaning adding new features to the our software, is done via packages. Okay. So Niranjan says, which language R is written? Interesting question. So R itself is based on a language called S, which was there before, which is an object-oriented language. And most of the R is built on top of that S language. And however, a lot of packages in R are built using C, Java, or some packages are built using R itself. Okay, so there are a mix of multiple languages in there, but the core R is primarily built using C. Okay, so you are building a language on top of a language in a way. Okay, and another very, very important characteristic of R is that it stores the data in memory. Okay, it runs on a single machine and it stores all the data in memory. Okay, so if you want to process a particular data set, the R instance that you run on your machine will read it from the disk, puts it into the memory, and then subsequently operates on that memory. Okay, so obviously that's a limitation, right? First thing, you are operating on a single node, so you cannot deal with large data sets, or you cannot do a distributed processing. And since it stores the data in memory, you are limited by the amount of main memory that is available on that particular machine. Okay, so if you have 4 gigabytes of RAM, and then probably 1 gigabyte will go for the operating system, depending on which operating system you work on. And there's some memory that needs to be allocated for all the other services that are running on your machine. And once all that memory is taken by those services and operating systems, then the remaining, let's say 2 gigabytes is available for R. Okay, and the data has to fit in memory, and therefore the largest data that you can analyze is 2 gigabytes, right? So that's the limitation. And the integration points that I was talking about, which Oracle, IBM, EMC, all these companies are trying to make in terms of integrating with R, is essentially to deal with this limitation. Okay, how can we make R work on large data sets that are sitting on many machines in the cluster? Okay, so it tries to address the problem of single machine as well as problem of storing it in main memory. Okay, and it also has advanced graphics so that you can do visualizations, and it has nice development tools including GUI, and there are a lot of other things that you can do, and you can connect to many databases or data sources so that it's easy to import and export data from your R instance into those other data sources, whether it's a relational database or a Hadoop cluster or something else. Okay? Any questions? Okay. Yeah, this is just showing the popularity of R compared to other related softwares, like primarily SPSS, SAS. So SAS and SPSS are obviously proprietary. You need to pay in order to get those softwares, and SAS especially is extremely expensive than SPSS and others, whereas R is completely open source, so it's easy to kind of deal with it. Okay. If you are working in SAS already, this chart kind of shows how SAS and R are different, but I mean, we are not interested in the difference for this particular class. Primarily, R is open source, SAS is proprietary, R is on a single machine, whereas SAS can run on multiple machines, and it's not limited by the main memory and stuff like that. Okay, this question probably is not very interesting. Okay, custom functions can be easily created in SAS or R. Primarily R, absolutely. And yeah, this is an interesting question. Most of the functions in R are written in Java, R, C, or Fortran. Okay, the majority of the functions. Oh wow! To my surprise, many of, actually all of you who are answered it correctly. Okay, as you guys said, most of the functions in R are implemented in R itself. Okay, and that's a pretty nice feature. That means even the core R is powerful enough to kind of build much larger and much more focused packages. Okay, and finally there's R and Hadoop integration. So we said R is single node and limited by main memory, and Hadoop is a distributed data platform. So how can I combine these two, right? R is nice little language that I can do for doing my data science, and Hadoop is a very powerful platform to work on large data sets. So how can I kind of get best of both? Okay, and that's essentially R and Hadoop integration. And we are going to look at a couple of packages which enable that integration. Okay, and these packages are developed by a company called Revolution Analytics. Again, these packages are also open source, and therefore you can download and work on your Hadoop datasets using R. Okay, we are going to learn that later in classes. So the difference between R and RStudio, Kunal, is R is just a basic command line. RStudio is some bells and whistles around that command line, which will help you in productivity and user interface and stuff like that. So RStudio is just a makeup given to R. The core execution engine is still R. It's like Java and Eclipse, right? You can develop your Java code in Eclipse, but the ultimate compilation and execution is done by the JDK and JRE. So similarly, R is the core engine. RStudio is just the makeup given on top of it. for better productivity. Okay, so what is R? R is essentially a suite of software facilities for data manipulations, calculations, and graphical display. Okay, so you can do pretty much the entire life cycle of your data science exercise, starting with importing the data from external sources or from your hard drive in most common formats like CSV and delimited and so on. So you can import the data and you can do some basic data transformations and data manipulations, as well as you can do calculations on the data, which include modeling and scoring and whatnot. And then finally, you can also visualize the results. So there's an end-to-end processing can be completely done in R. You don't need to like go back and forth between different systems. Okay, so it has an effective data handling and storage facility, and it has a suite of operators for calculations on a wide variety of data types. We are going to look at them today, and a large integrated collection of intermediate tools for data analysis, which is essentially getting the packages and also other basic data transformation methods that our language itself has. And you have graphical facilities for data analysis and display. Okay, and R is entirely developed on top of another object-oriented language called S. And since it's built on a language and R itself is a language, like any other programming paradigm, you also have conditionals like if-else statements, loops, while loops, for loops, and also you can define your own functions just like any other language, and obviously some input and output facilities. Okay, so that's just the basic of R. Okay, so Mohan has a question here. How different is R or R Studio from Revolution R, which is a paid software? So I think we briefly talked about it yesterday. So R is open source, and R Studio, Revolution R is just a distribution of R. Okay, it's like Linux and Red Hat. Right? Even though it's Linux is open source, as an enterprise, if I want to use Linux, I will go to a distribution company which will maintain that software in a stable condition and who can help me with the answers. So Revolution R is like that. It's a distribution company which takes open source R, package it in a nice manner, and give it to enterprises so that enterprise has a contact point for support. But on top of that, on top of the basic packaging of R, they also add additional packages for doing parallel processing using R. And we will see some of the packages that are available, but there are also some proprietary packages which you will get only if you pay for them. Okay. Okay. So what are the basic, and since we said R is a language, it has a type system, right? And there are two important classes. This is nowhere exhaustive representation of R's data types, but some basic ones which are must to know. Okay, first one is the variable data types. You have some numeric attributes like numbers or integers, and you have strings, you have logicals like Boolean values, true or false, and you have something called factors, which are like typically in the context of machine learning, they are referred to as categorical attributes. So imagine, so let's consider two attributes, temperature as well as shirt size. Okay, the domain of values for temperature is just real values, right? My temperature can be 21.2, 21.4, 21.56. It's a numeric value with certain range, of course, but it's a numeric value. Whereas shirt size is, on the other hand, it has like predefined categories, right? Like a small, medium, large, extra large, and maybe some plus size. Okay, there is a fixed domain of values, a discrete domain of values from which your records will take some value. Okay, so those kind of categorical attributes are typically represented as factors, and factors have different levels. We will get into the details, but at this point of time, that's all you need to know. It's just think of it as like a categorical attribute with a fixed domain of values. And then there's more more complex data types like data frames, which are essentially a combination of the basic data types. It's like a structure on or a union in other languages. Okay, it's just a container with multiple data types within that. And there are tables and matrices and stuff like that. We'll go into each of those details now. So instead of showing too many slides, we'll just get to this place. I'll close my script. I don't really need one. Actually, let me increase the font size for people to. Okay, is this visible for everyone? Okay, so first thing you need to know is R can obviously represent numbers. So I can say 1, I get a value back 1. I can say 2, I get value back 2. 2.2, I get 2.2. Okay, that's just so each of this is a statement, and since it's an interpreted language, as soon as I press enter, the entire statement is given to the R execution engine. And since it's just an expression containing a value, it executes and gives back the same result. Okay, and I can give arithmetic expressions as well, right? I can write whatever I want. I get the final result. R will evaluate the entire expression and gives me the result of that expression. Okay, so I can use R as a calculator as well, right? Anything, or 2 by 5 is 0.4 and so on. Okay, so at the very minimum, R can be just used as a calculator because it's interpreted as in when you enter some expressions, it will quickly execute and give back the results. Okay, and next level of thing one should know is something called as C function. Okay, C stands for concatenation. And what it does is it takes primitive values, concatenates them together to create a list of values or a vector of values. Okay, so I can say C of 1, 2, 3. Then I get a vector of 3 values with 1, 2, 3 in it. Okay, it's like an array. So essentially we created an array with 3 primitive values. Okay, and so C is a built-in function. Okay, and so remember I was telling you about this help page. Okay, how do I, and this is a place where I can look at the help available for functions. Now the way I get to the help is essentially on the command line. I need to say question mark followed by the function name. So C is my function name, so I'll say question mark C. Okay, it shows me the help page for the C function. Okay, here you can see this is a function name. Base is a package in which that function is present. Okay, If it is the foreign package, I'll get C in brackets foreign. So essentially, this is a function name, this is the package name. And then the description of that function, some usage scenarios, the type of arguments that you give to that particular function, and some details, and at the end some examples of using that function. Okay, every help page in R will have a similar structure. Okay, description, usage, arguments, details, and some examples. And whenever possible, I'll try to show you the exam help pages. That way you kind of get used to looking at the help and get used to understanding how to read those help pages. Okay. So as I said, C of 1, 2, 3, 4, 5 is essentially a vector of length 5. So I can say, I can assign, obviously I can assign values to variables, right? It's not just a calculator which are just doing computation on the fly, right? I need to be able to store values into variables and then use them later on. And the way you assign a variable is simply by using a assignment symbol, or you can use this left arrow, okay? Less than and then hyphen. So each of these can be used for doing the assignment. So I can say A is equal to 2. So there is a variable called A which got the value 2. So if I just say A, I get the value 2. Okay. Similarly, I could have said B is assigned 3 with the left arrow, and then when I say B, I get 3. Okay. And obviously, I can write expressions using A plus B. Okay, some random expression. I can basically, like any other programming languages, you can mix and match the literals as well as the variables into an expression. Okay, and similarly, I can say C of A comma B comma A plus 1 comma B minus 2. Okay, that's possible too. So each of this is an expression, and I'm evaluating all those expressions and then finally combining them into a vector. Now, vector itself is another object in R, so I can assign it to another variable. So I can say vec is equal to this. Now I can say vec is essentially a vector. Okay, so and there is this function called type of, which essentially tells you the type of a particular variable. So if I say type of A, oops, not A0. So yeah, here there is no object or variable with A0, so it complains. Type of A is double, and type of B is also double. Type of vector is also double because the individual values stored in vectors are numeric values. And there is another function called class. Okay, so what that class is essentially tells you is indicates this a numeric vector, and for other complicated, other complex data types, you will see it's a matrix, it's a data frame, and so on. Okay, so we often use this functions like type of and class in order to check the type of those variables. Okay, any questions so far? Write your questions whenever you have one, and I'll pick it up as and when it's possible. Okay, that's about the basic integer variables. And there is a function called ls. Not surprisingly, ls will tell you what are all the variables that are available. Okay, not like the list of files on the command on the file system, but ls gives you the list of all the variables. And since it's a function, I can also look at the help of that function, right? I can say question mark ls, and it will open a web page for the help. Again, there is a function name ls, and it belongs to the package base, which is a core package. and there are a bunch of parameters it can take, and some descriptions of those arguments and some help example files. Okay. And similar to ls, there is also directory command. Okay, before going into directory command, so there is something called get wd. Okay, which is essentially says it's a get working directory. Okay, the current directory in which you are present, and you can obviously change the working directory by saying set wd. Okay, I will say c say Edureka. Okay, so I now changed it to a different folder on my system, and I can say dir on that, and I'll see the list of files that are available on that particular folder. So ls is the list of variables in your R instance, and dir is the list of files and directories in the current working directory. Okay. So Vijay asks a question, how can we pick up on all the commands, any books or help? So Vijay, I mean, these are some things you will learn on the go, and whenever you want something, you can look into help pages or you just Google it. So it's, I mean, definitely there are books on learning R. If you would like, I can refer to some. On LMS, I can put up a list of textbooks and a list of references that you can find it to be useful. I can put them up, but it's usually you learn it on the go. Okay, it's not like you sit there and learn all the commands and then you start doing modeling. Most likely you will kind of, whenever you need something, you will look up for the corresponding functionality in R. Okay, Mohan asked a question, when we assign a value to a variable, will it be available till the end of the session? Yes, it will be available until the end of session unless you remove that particular variable from your instance. Okay, and he also asked, when I say a equal to 2, till when will the value of a, okay, yeah. Whenever you say a equal to 2, it will have value of 2 until you reassign a value to a or you delete a variable a. Okay, yeah, definitely. You can definitely assign new values to it. So I can say a equal to 3 now, and now a will have 3, obviously. Okay. So Madhura actually have a suggested book here already, R in Action, Data Analysis. That's actually a good book, Madhura. So it's called R in Action, Data Analysis and Graphics with R. Okay, by Bob Kabakov. Okay. So Partha, whatever you're seeing probably is a basic R console. It's not R Studio. But anyway, we can get to those questions at the end of the class. So when you're in R Studio, you can, as I mentioned, you can open a R script. I can write any commands here. Okay. Any commands here, and then I can save it to a file if I want, or I can just execute from here. So that's how you can develop code and store all your script files. Okay, so now that we saw the basic type called numbers, right? And the next type that you should be aware of is strings. Okay, so I can say hello or hello with a bow. That's a string. And just like any other variable, I can again say hello. So there's no restriction of types. Previously, I assigned an integer or numeric value to A, and now I'm assigning a string value to A. That's totally fine, because these variables are kind of typeless, and you can change them. And I can say B is equal to world. Okay. Now I can say type of A, which is character, which is meaning it's a string, and type of B is a string. Okay. And just like in numbers, I can combine these values into array. So I can say C of A comma B comma some other strings if I want. Okay. So I created a array or a vector of 4 values. First 2 are coming from the variable hello world, and then some other constant strings. Okay. So you can create a combination of strings as well, or I can even give a value 2, which will essentially get into a string 2. Okay, string representation of the variable. Okay, and you can concatenate strings by something called as paste. Okay, 1 second, there's a question here. So whatever calculations that we are going to perform, are these going to be saved in the working directory? So the calculations are not stored, right? Everything is in memory. Unless whenever you quit R, it will ask you whether you want to save the entire session. That means all the variables, it's like putting in hibernate mode, right? Whenever you put your computer in hibernate mode, all the program state is stored on the disk, and whenever you come back, it will come up exactly the way you shut it down or put it into hibernate mode. So similarly, you can save the state of a R program whenever you close it, and that's when you store all the variables and the corresponding values on the disk, and then you can kind of resume back from wherever you left off. But like currently, as of now, whatever variables I created, they are just sitting in memory. They are not on the disk, or they are nowhere. If my R console crashes for whatever reason, I will lose all my data. Now, if I say close, it will ask me save workspace image to .r data. That's the way they store the entire workspace. So if I store it and load this particular instance, I'll get the variables back again. Okay. If I don't want to save it, I say don't save, and whenever I open, I get a new instance of R with no variables in it. Okay. Can we assign values within C command? I don't know what you mean by assign values within the C. So you want to say A equal to B and 2, like that? That's actually not possible, because A is essentially treated as the name of that particular component instead of treating A as a variable. Okay? Yes, so when you say C of A is equal to 1 and B is equal to 2, or actually let's take other variables X and Y. Okay? When I now say X, it says object not found. So X is not treated as a variable here. Instead, it's treated as a name to this particular component in your array. Okay, so you can give names to individual values, and these are the names that are given. So these are not the variables that you will see outside of the C command. Okay. Okay, Vijay has another question. So if the commands are in the file, once we execute the file, will our system will reset, or do we need to manually reset and include the reset command in the file? Not sure what that is, but hold on to that question, Vijay. We can get back to it at the end of the class. Just remind me again at the end of the class. Okay, so let's continue. So we are we are able to create an array of strings, and I can also concatenate strings using something called paste. And like any other function, I can take a look at the help if I want to. So I can say paste a comma b comma, or I can give a hello world r and so on, right? List of strings, and then there's a separator. Okay, if I say comma, all these individual strings get concatenated with comma. Okay, and I could have said colon, or I could have said space, or I could have just give nothing. Okay, so it's just a separator with which all these individual strings need to be concatenated, and obviously they need not be just literals, they can be variables as well. Okay, these are some basics. You can play with it to explore more, but I'm just giving you some idea of how these functions work. Okay. Similarly, so we said we can create a vector of strings, right? C of a comma b comma I comma r. Okay, so if I say type of vector, it's a character, and if I say class of vector, it will again say character, because it's like a vector of character strings. And since it's a vector, I can just like in C, I can look at the length of the vector by saying length of vec. Okay, there are 4 elements in it, so I get length of vector as 4. Now, in the paste command, I can actually also say paste vec, and I can say collapse dot. Okay, that's also like concatenating all of my individual values in the vector and concatenate with this particular delimiter. Okay, so I'm collapsing the list of all the values in this particular vector, and then separating them with a whatever string that you provide here. Okay, I can even provide some more complicated string as well, not just a single letter. Okay, that's about the basic string functionality, and there are more string functions, like you can say str split, which is essentially for splitting a string. You can again look at the help for it. So I can say str split of s. I need to give the split attribute as well. That means with which I should split, what is the pattern. Okay, that's a regular expression, so I can say, or I can do that. It's basically splitting of a string by given delimiter. Okay, one thing you need to notice in this particular help files is this is a signature of that function, right? You will see these equal to false, equal to false, equal to false. So what does equal to mean in a signature? Can anybody tell me? This is standard syntax in many languages. What is the meaning of an equal to in the function signature? Yes, so it's a default value. Okay, if you do not provide any value for it, it's default. And since this guy has no equal to, so that means this guy does not have any default value. So whenever you invoke str split, you have to provide a value for it. And that's why you got an error before. When I say str split of A, I'll get an error saying split is missing, the second one. Okay, and in R, every attribute is named attribute. So I can say actually split is equal to underscore and then our split is equal to underscore x is equal to A. Okay, so what I'm saying is I can give the named attributes essentially. So these are the names of my arguments, and I'm providing the corresponding values for each of those arguments. So that is same as str split of A comma underscore, exactly the same, and it's even same as okay, that's also same. Since it's named attributes, the order can be anything. Okay, if you do not provide any names, it should follow the order that's given in the signature. Okay, that's obvious, like any basic programming language. Okay, and let's go to data frames, or actually let's go back to our slide deck. So these are a lot of string manipulation commands. You can do grep, you can like str split and different cases, two lower, two upper, substrings, concatenation using paste, and you can quotation, you can quote a string and so on. There's so many other things you just need to explore depending on your requirement. Okay, and there are a lot of plotting capabilities as well. We'll see at the end of the class some examples, or we can leave it to the end. So you can create bar graphs, pie charts, line graphs, and scatter plots and whatnot, right? Many type of graphs are possible. Okay, and we already saw that R can be used as a calculator where you can just simply write some expressions. So these expressions need not be just plus and minus. You can also give some mathematical functions like log and exponential, sine, okay, sine, cos, trigonometric functions, and this particular symbol, caret symbol, is for power. So if I say 2 power 3 is essentially 8, 2 to the 3, right? And I can say log of 2, I get the value of log 2. And by default, I think it gives base 10. Okay. Oh, default is a natural logarithm. Base 10 would be 0.3 something. So I can say log 10 of 2. Okay. So that's essentially log of 2 with the base 10. And this one log of 2 with base e, natural logarithm. Okay. So there are so many mathematical functions as well which you can explore. Okay, we already said this is a caret symbol is for exponentiation, and variables can be assigned using assignment symbol. Okay, and we already saw the combine or concatenate method. And scan is a method to basically read values from the standard input. Okay, so if I say, just to use the same example, z is equal to scan, then I can give a list of numbers. And whenever I finish, I just say enter. So it read 3 items. Now if I see z, it's a list of 3 items, the vector of 3 items that I just entered. I can see class of z. I'll get numeric, which is a vector. I can say length of z, obviously 3, and like that, right? So you can read in stuff from the standard input, which typically you don't do it. Actually, I never use scan in my experiments or exploration anytime, but that's a functionality if you would like to use, you can use. Okay. Any questions so far? So I think there's a lot of questions about what is the best way to explore R, the list of functions. So at least the way I learned is just on demand. Whenever I need something, I look up the help files, or I look up Google how to do it, and I'll run into a new package or a new function to do that particular computation. Okay. But as Madhura suggested, there is one book, R in Action, and there are many other books I can point you to. And there's also R language guide, which gives you the complete information about, like if I say R language guide, yeah, it's a complete list of all the manuals. So if I go here, Introduction to R, I get everything. Vectors, assignments, objects, the complete help, right? This is like reading the language guide from scratch. So a lot of things may be unnecessary for you as you start, but if you want to go and pick up R in that fashion, you can start from here also. Okay. But typically, for languages like this, since it's so vast, you can't really sit down for 2 days and say, okay, today I'll learn R. It's more like you start doing some computations or some tasks using R, and over the time you will pick up stuff. Okay. So can you please explain vector? So vector is essentially a list of values, right? Array of values. I shouldn't say list, but it's an array of values. Okay. And since it's an array of values, you have a particular length and you can index into it. So actually one thing I haven't showed. So we have vec, right? Which is a array of 4 strings. Okay. And we already saw that length of vec will give me 4. So just like in C or Java or any other language, I can subscript into that vector. I can say vec of 1 is hello, vec of 2 is world, vec of 3 is hi, and so on. Or you can even I can say like this, vec of length of vec. Okay. So length of vec is 4 and vec of 4 is R. Okay. So just like any other array, you can subscript into it. Does R support templates? So it does have support for templates because it's kind of built on top of this language called S or S4, which is an object-oriented language with a lot of features in it. But typically, you don't really have to go into such overloading or such generic methods. At least I never had to use those kind of advanced features in my code. Okay. So any questions so far? Any other questions? Okay. So next one useful operator is essentially called just a colon, which is like a sequence operator. So I can say 1:10. That means I'll get a sequence of numbers from 1 to 10. Okay, and everything is stored or returned as a vector of values or an array of values. Okay, I can say 1 to 3 or 1 to 5 and so on. Or I can say my ARR is equal to 1 to 5. Okay, then ARR will be an array of 5 elements starting from 1 to 5. the default increment in colon operator is essentially the increments of 1. Oh, so Debagna has a question about, I think I did vec of hello world A comma B, right? So actually with C here. Okay, this is just combining, we are not really assigning value to A and B, we are using the values in A and B to construct this variable called vec. And like C operator, like we know, it just combines all these values into a vector. Okay, and we got hello and world again because A is hello and B is world. Okay, just to avoid confusion, I'll change these guys. XYZ ABC. Okay, so now my vec is going to be an array of 4 elements, and first 2 elements are ABC, XYZ. Third element is the value of A. Fourth element is the value of B. Okay, is that clear, Debagna? We are just creating an array with some variables as well, not just simply literals. Okay, now going back, we were looking at the sequence. 1:10 is 1 to 10. Okay, and yeah, I can assign it to anything. Okay. Along with the colon, there is also a function called seq, which is for generating a sequence. Okay, I can, if you want, you can look at the help, which takes 3 arguments mainly, from, to, and increments. And there are other arguments as well, but so I can say sequence of 1, 20 with the increments of 0.5. Okay. So I get 1, 1.5, 2, 2.5, and so on. Okay, it's simple, right? Generate a sequence starting from 1 until 2 with the increments of 0.5, which is same as I could have written like that. Okay, named arguments like we see here. These are the names of the arguments from, to, and by. Okay, and it need not be increasing sequence. It could have actually been a, if you do not provide the increment, the default is 1. There's some math involved there, but you can see here 1, 20 will give me increments of 1. And similarly, I can do a decrement, decreasing sequence. Sequence of 20, 1 will be a decreasing sequence. Or I could decrease in increments of or decrements of 0.5. Okay, I can give a minus value, and obviously this one will fail because I want to go from 20 to 1, but the increments is a positive value. So obviously that will be an error. Okay, so that's just 2 other ways of creating a vector. Or a sequence of values, one with the colon and other with the sequence. And with colon, the default increment is 1. With sequence, you can provide the increment either positive value or the decreasing value or the negative value. Okay, that's just a few more examples about colon and sequence. And similarly, there is a function called rep for replicating the value. Okay, I can say rep of 3, 10. That means I want to take the value 3 and I replicate it 10 times. Okay, I get 10 3s. Again, the return value, whenever you see something like this, is a vector. Okay, it's a vector or an array of values with 3. So I could have said length of rep of 3, 10. So what do I get? Length of rep of 3, 10. What do I get here? Okay, only one answer so far. 2, 3, 4. Okay, yeah, obviously 10, right? Because rep of 3, 10 will give me a vector of 10 values, and I'm getting the length of that vector. So obviously that's 10, which is my repeating factor. Okay. So Sai Siva has a question. Okay, let me unmute you. You can ask that question. Okay, Sai Siva, go ahead.
Yeah, so I had one R script open. I had a couple of R script open in Cran Studio, and I assigned ABC value in one of the scripts, and I didn't assign a D value. I tried it in another script file. So it took it. So the values basically were assigned, when
I see where you're going. The value
Okay.
from one script went into the other script, right? That's
Exactly.
what you're getting.
Yes, exactly.
So that's because the script is just an artifact that you created. It's not like a C program where I have two C files or two Java files, which I compile independently and then run them. So there are two independent execution units there, right?
Yes.
Whereas
Exactly.
here, script is just a way to store your statements. I can, but ultimately they are executed in this command line in the execution engine, right?
Okay.
So
I got it. Yeah, I just want to clarify because if I'm doing some analysis, then I have to be really careful, right? I have to really clear the memory or...
No, not like that. So if I write a script and if I just execute that script from the command line, I execute all the commands in one go, then there's not really the R shell will be spawned for that particular script, and you execute all the commands and then you quit the shell. So there's no variables propagating from one script to the other script. But if you are opening this R Studio and then I'm creating a lot of scripts here, 3 scripts, and then I'm kind of reusing the variables across the scripts, then you will obviously run into a problem, right? Because they're all executed in this particular place.
Okay.
Okay?
Okay. Got it. Thank you.
Yeah, no problem. Yes, Sanjeev. I wanted to take that question later because it was not directly related to what I was talking about, the length and the vector and all those things. That's why I did not answer the question. So how can we save our script we just created into a file? So like from here, from the history, I can just simply click save and it will create, you can save it into a file. Or I can write my script here and then I say save here. Okay? So there are two ways. I can write my script here and I save here, or I can just simply save the entire history into a file. Okay? So, don't get offended if I don't answer the question immediately. It's just that I'll try to take it whenever it's appropriate. And it may be possible sometimes I'll miss the question, and at that time you can raise it again. Yes, that's true. From next time I'll acknowledge that I'll answer that question later. Yeah. Okay, let me just close all this, guys. Okay, so we talked about length and we talked about rep. and the sequence commands. So that's exactly this. Colon operator is a series of or a sequence of integers between the from value and the to value. Okay. And obviously we saw this already. I can create a sequence, either a decreasing sequence or an increasing sequence in whatever increments that I want. Either it's negative increments or the positive increments. Okay. So that repeat, whatever we just saw, is not just for numbers. We can even repeat strings, right? If I say hello and 5 times, I'll get hello, hello, hello 5 times. Okay. Yes, I Siva, both are exactly the same. This one and assignment, both are equivalent. Both mean assigning a value into a variable. So can we run the saved script from within the R shell? So from command line, you can do it. Like Windows command line, there's something called R script, or depending on your Windows or Linux, there's a different command. You can run from there. And here you can simply source it. That means it's like I open a script, I have a bunch of commands. Okay, this is new one, new one, but I could have loaded a script as well. I can, let's say, save it. Let's say temp.r, and let's say I close it. I could actually open that script again. And then I can select all of them and I click run, and everything will get run one after the other. Okay. Okay, great. Any other questions, guys? Am I going too fast, or is it okay? Since these are kind of basics, I thought of going a little. Oh, okay. Okay, I'll try to manage this pace then. Yes, Sanjay, it's anytime, it's interactively, because, that's why I said it's a interpreted language, and therefore you execute one statement at a time. So even if you give 100 statements to it through a file, it will still go one by one and execute. Unlike a C program, which tries to compile all those 100 statements together and then run at once. Okay. Yes, Sanjeev, again, we can highlight whatever lines we want to execute. Okay. So actually, let me show you that. So let's say I take all these commands from my history and I'll say to source. They will go into my R script. If I say to console, they'll come here and they get executed. Okay. So they are all pasted here. Now they all executed one by one after that. Okay. Instead, I could have, let's say, selected some other columns, some other commands. I can say to source, which will go into my source file. And here, if I select all of them and run, then everything will run. Or I can actually select only just by default, the current line will get executed. Or I can select, let's say, 3 lines and execute 3 lines. So it's all up to you. Okay, any other questions? Oh, the current line is essentially wherever your cursor is. So currently my cursor is in the first line. So when if I say just run, that length of vec will get executed and my cursor moves to the second line. Now if I say run again, the second line get executed and the cursor move to the third line and so on. So wherever your cursor is, that's your current line. Okay. So let's go back. Yeah, so we were saying rep can be used for strings, or you can even replicate an entire series, right? So I could say we already know that 1:3 gives me 1, 2, 3, right? I could say rep of 1:3, comma, let's say 5 times. Okay, so essentially I'm replicating whatever this object is, whether it's an integer value, string value, Boolean value, or a vector or a matrix, whatever it is, I'm replicating so many times. So since this is a sequence or a vector, that vector is repeated 5 times here. Okay. You can even, so this actually, let's look at the help of rep. So here you can see rep of x, which is the object that you want to replicate. So it can be anything. It's an object or a vector or anything. And then the times argument, which is the integer vector giving the number of times to repeat each element of x. So what that means is, if I say simply 5, that means every element in this particular object will get replicated 5 times, or that means the entire object itself getting replicated 5 times. Instead, I can provide a different replication factor for different elements as well. So let's say 1, 10, and or 1, 5, 1:5. I'll say C of 1, 2, 2, 3, 4, 5, 6. Okay. What that means is, okay, let's look at the output and try to understand. So 1:5 is essentially 1, 2, 3, 4, 5, right? So we have a vector of values here, and we want to replicate it according to this replication structure. So I want to replicate the first element 2 times, second element 3 times, third element 4 times, fifth element 5 times, fourth element 5 times, and the fifth element 6 times. Okay, that's why you got this 2 1s, 3 2s, 4 3s, and so on. Okay, so that would be same as rep of C of 1, 2, 3, 4, 5, which is same as 1:5, and I'm giving the replication structure. Okay. Again, that's same as sequence of 1, 5, that. Okay. So essentially what I'm trying to say is that whatever you are providing for the replication factor, it can either be a single number, which will apply to every element in the object, or it can be a vector itself, which will give you the detailed replication structure. Okay. Mohan asks an excellent question. Since we are all talking, I mean, we want to do machine learning and statistical analysis, the fundamental thing we should be able to do is generating random numbers, right? From different distributions, whether it's uniform distribution, Poisson distribution, Gaussian distribution, and so on. So there are multiple functions to do that as well. There's a function called RUnif. That means it's a R uniform random number. Okay, you can again look for the help if you want to. And there's R norm for Gaussian random numbers, and so on. So if I say RUnif of 10, okay, that means I get 10 random values uniformly distributed between 0 and 1. Okay. Similarly, if I say R norm of 10, I get 10 random values, or 5. I get 5 random values between from normal distribution. That means mean is 0, standard deviation is 1. Okay, so I get a bunch of values which are normally distributed. Yes, Madhura, I think whatever you're saying is absolutely true. For data science, acquiring few basic functions in R that are listed on our PPT slide should be good enough to get started. And in real world, we need to figure out the logic as we go. Exactly. Okay, so here we could repeat the series. Since it's just set 2, the entire sequence is replicated twice. Or I could give the replication structure here. Okay. So here, if you see, it's basically you are using the rep itself as a replication structure to the other rep. Okay. So rep of 3, 6 will give me 3, 3, 3 6 times. And I'm giving that as a structure of replication to this sequence. That means every element in this sequence is replicated 3 times. Okay. And this we have seen already. We can give 2 vectors and you replicate accordingly. And you can sort as well. Let's come to this in a minute. Okay, let's look at C-bind and R-bind first before we look into sort. Okay, and so in machine learning and in many statistical analysis, the fundamental data structure is matrix. Okay, whether 2-dimensional matrix or multi-dimensional matrix, it can be anything, but mostly 2-dimensional matrices. Okay, 2-dimensional matrices are the ones that we learned back in our high school in our linear algebra, right? Matrix additions, matrix multiplications, transpose, and all those things. And we can create matrices from vectors using R-bind and C-bind. Okay, so let's construct 2 vectors, x1 or vec1 is equal to C of 1, 2, 3, 4. And vec2 is equal to 10 to 20. Sequence of 10 to 40 in the increments of 10. Okay, so I have my vec1, 4 elements, and vec2 again 4 elements. Okay, let me close this one. We don't need space. Okay. Now, if I say C-bind of vec1 and vec2, that means I'm binding these 2 vectors in the column dimension. Okay, so I get exactly that. So I'm taking each of these vectors and then putting them together, attaching them from the column wise. Okay, so I get this matrix of 4 rows and 2 columns. Okay. Similarly, I could do R-bind, which will attach them in a row-wise manner. So R-bind of vec1 and vec2 will give me the transpose of that matrix, right? So we are taking 2 vectors, vec1 and vec2, and we are attaching them together. We are binding them together in row dimension. Okay. So, I mean, we already know in any matrix there are row dimension and the column dimension, right? So, C-bind and R-bind accordingly binds individual vectors in appropriate dimension. Okay. Now, if you actually do MC is equal to C-bind of vec1, vec2, we stored this result into a variable called MC. Now we can see the type of that variable. I can say type of MC, which is double, because the individual values that are stored in this variable are doubles. If I say class of MC, I get a matrix. Okay. So essentially what this is it's a MC is a matrix of doubles. Okay. And since it's a matrix, it has row dimension, column dimension. I can apply transpose, I can apply matrix addition, matrix multiplication, inverse of a matrix, and whatnot, right? All the operations that you can do on a matrix. Okay, is that clear? Row bind and C bind, I mean R bind and C bind. Okay, good. So if we remember our high school days, we have matrices as okay, MC is that, and let's do MR, which is the result of my R bind, vec1 and vec2. Okay, my MR is essentially the transpose of that. Okay, now for matrices, obviously we want to know like basic things like length of the number of rows, number of columns, and the total number of elements, right? So there's a function called nrow, and you can pass in a matrix. It gives me the total number of rows in the matrix. Okay, so in MC we have 4 rows, and then similarly ncol will give you the number of columns in the matrix. Okay, ncol of MC is obviously 2 because we have 2 columns. Now there's also, just like we saw length of a vector, we can even say length of a matrix, which is 8, which is exactly equal to the total number of elements in the matrix, which is exactly equal to nrow times ncol, right? So length of MC is equal to nrow of MC times ncol of MC. That's obvious, right? Total number of elements in the matrix is equal to my number of rows multiplied by number of columns. Okay. And since it's a matrix, I can say transpose of that matrix. Okay. We exactly get this. Okay, so I can say transpose of matrix plus MR. Okay, I'm transposing this matrix and then adding this matrix. Okay, then essentially I get this result, obviously, right? So essentially what I did here is some linear algebra. I transposed a matrix and then did a cell-wise addition between 2 matrices. Okay. So these linear algebra routines are the ones that you use very often for your, if you want to build your own models and write your own machine learning code. Okay, similarly we can do matrix multiplication as well, right? So I can say MC. Okay, before that, if we summarize basic operations on matrices, there's transpose, there's plus, there's minus, there's a star, there's division. Okay, these are all, so this is the transpose, T is transpose. All these are just element-wise operations between 2 matrices. Okay, cell-wise operations. Now, instead of that, there's an operator called percentage star percentage. It's essentially a matrix multiplication. Okay, not a cell-wise multiplication, but a matrix multiplication. Again, you need to remember our good old school days where we learned these matrix algebra. So MC and MR are 2 matrices, and this particular operator is for matrix multiplication between the 2 matrices. And in order to do that, the basic criteria is that number of columns in the first matrix should be equal to number of rows in the second matrix. Okay, that's basic criteria for matrix multiplication. And here we have the criteria valid because number of columns in MC is equal to 2 and number of rows in MR is equal to again 2. So I can do matrix multiplication and then I get a 4 by 4 matrix, right? That's obvious. We multiplied, we took a 4 by 2 matrix and matrix multiply with 2 by 4 matrix, then we get a 4 by 4 matrix. Okay, that's a basic matrix multiplication. So these are some of the operations that you can do on matrices. So we started with individual values. We used C function to create a vector of values, and then we used R bind and C bind in order to make these vectors into matrices. And then we can do some matrix algebra on it. Okay, that's what we have seen so far. Okay, so we already saw this. cbind function combines vectors into matrices. I can even actually, yeah, good. So the cbind or rbind takes matrices themselves as inputs. Okay, they need not be vectors. Okay, so we started with vec1, we started with vec2, and then we created MC, right, by combining them in using cbind. Now I can actually again say cbind of MC comma vec1 again, or vec1 plus 1 if I want to. Okay. So what am I getting? I'm taking my entire matrix MC, which is a 4x2 matrix, which is this, and then I'm adding another vector or another column because I'm using a cbind with the values vec1 plus 1, okay, which is the result of this vector plus 1, which is 2, 3, 4, 5, and you are binding them in the column dimension. Okay. So essentially what I'm trying to show here is I can do even MC. Okay. That means I'm attaching two matrices in column dimension. And similarly, I can say rbind of a matrix as well. Rbind of MR. Okay. So cbind and rbind don't just operate on vectors, but they take matrices as input. So you can concatenate matrices in row-wise format or the column-wise format. Okay, so that's all cbind and rbind. So is matrices a data type? Yes, you can kind of consider as a data type. Need not be, it's not a primitive data type like numeric and string, but it's a more complex data type, but yes, because there are certain operations that are defined on top of matrices, and that's why it can be treated as a data type. Okay, any questions? So should we take a break, a small quick break, since it's kind of halfway through the class? So matrix is also referred to as class. I know what you mean by that, but so I can invoke class on MR. So class is a function which basically tells you the type of, the class of that particular object. Is that answers your question, Sanjeev? Sanjeev, does that answer your question? You did type on a matrix and it gave a double. Oh, that type is essentially, okay, type of MR is double because type of gives you the type of individual values in that object. Okay, whereas class gives you the type of the entire object. Okay, that's why by combining these two, we can now say MR is the matrix of double values. Okay, so type will give you the type of individual values in that object, and the class gives you the type of the entire object itself. Class, is it a command or a query? The difference is kind of subtle, right? It's basically in the way it's implemented, but you can just treat it as a function. Okay, class is a function which takes a object and returns the type of that object. Okay, and actually, since it's a function, you can also look at its usage. Okay. Okay, should we take a break? So as you all can see, I mean, we're just trying out different data types and different operations on these variables of different data types, right? And obviously you won't use R for doing just for these simple calculations and stuff, but you will build upon these and use these functions and capabilities for doing more complex data transformations and data pre-processing. Okay. Any questions before we proceed further? Okay. Okay, good. So yeah, we looked at how to construct matrices and how do we run some linear algebraic methods like transpose, matrix multiplication, and so on. And another important function which we especially use for combining multiple data sets is a join functionality, right? Like relational database join, you have something called as merge. Actually, before we go to merge, let's cover what a data frame is. So let's go back to console again. So let's take a look at a data set. So whenever you install R, it actually comes with some basic data sets, some primitive data sets. And one is called iris. Okay, iris is a data set which contains multiple columns. Okay, it's essentially like a table. You have multiple columns of which indicates petal length and petal width of different flowers, and also you have another column called species. So based on this sepal length and petal length, all this based on these attributes, you can kind of classify that particular flower as a species setosa. And there are some other flowers of species versicolor, and there are some other flowers of species virginica. Okay, so essentially this iris is a data set of different flower species and some characteristics about those flowers. Okay, and iris is actually very popular data sets. It's like people use it like a hello world example for doing classification type of tasks. Okay, to learn any classification, they try to run it using iris data set. So this is actually a data frame. So data frame is like a structure where you have individual components, and each of this component can be of any type. It can be numeric type, it can be Boolean type, it can be string type, or any other, right? So in this case, it has 5 columns: sepal length, sepal width, petal length, petal width, and species. Okay, each of these 4, the first 4 columns are of numeric type, and the last column is of type string. Okay, or factors. We'll see factors also in a bit. So on data frames, you can invoke a command called str, structure. Okay, it tells you what is the structure of a data frame. Essentially, it says the type of this particular object, which is a data frame, and it contains 150 observations or 150 records with 5 variables. Okay, these are the 5 columns that we have seen. So the rows are typically called as observations or samples or instances or records. So these are all different names for the rows. And the columns are called as variables or features or attributes and so on. Okay. And for each of these 5 variables, it gives you some more information here. So these are the 5 variables we have: sepal length, sepal width, petal width, and species. Okay. And each of this variable is of type numeric, 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 numeric. And the final one is called factor. We'll get to that in a bit. And then some example values of each of these attributes. Okay. That's what you get when you do structure on a data frame. Okay. So just to reiterate, data frame is essentially is like a container with multiple components, and each component can be of different type. Okay. So it's like a table, essentially. Now, so factor, as we talked before, it's like representing a categorical attribute, right? Like shirt size, shoe size. Those are fixed, defined categories from a discrete domain. So here, the species attribute or the species column has 3 different values: setosa, versicolor, and virginica. Okay, so these are like stored as strings, but essentially these are 3 categories for that particular attribute called species. Okay, and that's why they are stored as factors. Okay, whenever you have this categorical attribute, you R will store it as a factor, and by default, whenever it reads a string column from the data from a data frame, it is automatically treated as a factor. Okay, and so internally, whenever R tries to represent this data frame internally, it tries to replace all these string values with equivalent numeric values. Okay, instead of storing virginica, versicolor, and setosa so many times, it actually internally recodes saying setosa is equal to 1, versicolor is equal to 2, and virginica is equal to 3. And instead of storing the string values, it stores the corresponding numeric values 1, 2, 3 for simplicity. Okay, so that's why you will see here species is a factor with 3 levels. That means 3 distinct values. R has a terminology called factor and levels. Okay, factor is like a categorical attribute. Level is like the individual category in that particular categorical attribute. Okay, so here species is a categorical attribute with 3 categories or 3 distinct values, which are setosa, versicolor, and virginica, which is not shown here. It just showed ... and the example values of it. Since all our first few records are setosa, 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 they are all represented as 1, 1, 1. And the corresponding rows with versicolor, they will be represented as 2. And similarly, virginica will be represented as 3. Okay, so that's the internal representation of factor variable. Okay, is that clear about factors? Okay, great. Now we can do a bunch of operations on this data frame. The first one we have seen is just inspecting the structure of a data frame. And the other operation that you can do is summary of a data frame. Okay. And data frame is a very important concept. Whenever you read a data file from external source into R, it's most likely be a data frame. Most likely, it can be other things as well, but it's likely to be a data frame. So, so just pay attention to this particular topic for sure. So the next operation that we can do on a data frame is summary, which essentially gives you some summary statistics for each of the attribute in your data set. Okay. Sanjeev, yes. Whenever R tries to read a string value, it automatically treats it as a factor. Okay, unless you specify not to treat it as a factor. We will see an example of reading and writing the data sets. That's when you can you'll see how R converts strings into factors. But the default logic is whenever you have a string column, it will be treated as factors in the data frames. Okay. Yes, there will be situations where each string will be different. Like let's say if I'm importing employee data, there'll be employee name. Assume that every employee has a unique name. Then if you do not specify any extra parameters, whenever you read the data, it thinks that name is a factor column, and it will try to assign a unique ID for each of your names. Okay. If you want them to treat it as a string, you have to provide a special parameter. We will see what that will be. Okay. Okay. So let's get back to summary. So summary essentially tells us some summary statistics for each of the attribute in our data set. Okay. Now let's execute that. So you'll see 5 different columns here. And that's because we have 5 columns in the data. So for numerical attributes, it always gives you these summary statistics: minimum, maximum, mean, median, first quantile, and third quantile. Okay. So minimum, maximum, we all know what it is. The minimum value and the maximum value in that particular column. And the mean is the average, obviously. Median is a center value. Okay. First quantile and third quantile is essentially 25th percentile and the 75th percentile. Those are the values. Okay. So that is the summary statistics for the values in column sepal length. So similarly, sepal width, petal length, petal width, all these columns are numerical attributes, and therefore there will be summary statistics containing minimum, maximum, median, mean, and all those guys. Okay. And whenever you have a factor attribute or a categorical attribute, it simply tells you how many instances of each category exists in the data. So there are 50 with species equal to Setosa, and 50 with versicolor, and another 50 with Virginica. Okay. So these are the summary statistics that you can see for each of the attribute. So these 2 functions are essentially to just inspect what is contained in that data frame. Okay. So these summary statistics are also called as descriptive statistics. That's a branch of study from statistical point of view. Descriptive statistics are essentially some aggregates or some numbers which will kind of gives you an insight into the distribution of data. Okay. So like by looking at median, mean, these first quantile and third quantile, we can kind of infer how the distribution of data is. There are so many other things like mean, variance, standard deviation, kurtosis. There are so many other statistics as well, but by default, R gives you these basic ones with the summary command. Now, since a data frame is like a table, we can count how many observations are there in my data frame, or how many records are there, or similarly, how many columns are there. Okay. So just like we saw in the matrix, we can say n row of iris, which will give me total number of rows in iris dataset, which is 150, right? We already saw here 150 observations. Similarly, I can say n col of iris. Okay. Now, just like we indexed into a vector or an array, we can index into data frame as well. So I can say iris of 1, 1, 1, okay, which is first row and first column. So what is the value I have here? First row and first column is 5.1, okay. So that's why you get 5.1. So similarly, I can say iris of 1, close. That means I am taking all the columns in the first row. So I get the complete first row as an output. And similarly, I can examine 10th row, for example. I can examine 50th row. Okay. So that's the way to index into the data frame. And similarly, not just one column, one row, I can actually get multiple rows. I can say 1:3, this. Okay. We already know that 1:3 is essentially a sequence of numbers 1, 2, 3, and we are giving it as a row dimension. Okay. So 1:3 will give me 3 rows. Oh, okay. Yeah, I think that helps in looking at the commands one after the other. Okay, so 1:3 is essentially the first 3 rows. Okay, and similarly, I could have said 1:3 and 2:4 for the column dimension. So what it means is I'm taking the first 3 rows and then I'm taking second, third, and fourth columns of the data. Okay, I get second column is sepal width, and the third column petal length, petal width. So the 3 column values from the first 3 rows. Okay, so this is all different ways of indexing into the data frame. Okay, now the question, can we get the factor instead of actual string value in call 5? So whenever you print it, it always prints the string value, but internally it's represented as a factor, meaning the numerical value. Okay, and you need to do that conversion from string to numerical value, because whenever you run a mathematical model on it, let's say you want to do linear regression or some other model which will involve some matrix algebra, you can't obviously do a matrix multiplication when the values are strings, right? So to enable those kind of mathematical operations, you always try to convert strings into factors or internal numerical values. But by default, it always prints out the string values. Okay, I can even say iris of let's say 20 to 30 rows, and I want to get the 5th column, the species column. Okay, that's my list of values. And again, it's a vector. So as you can see, this is a vector of levels. So just like before, we can, if you want, we can store species 20 to 30 is equal to that. Okay, that's a variable I created, sp2030. And if I see class of sp2030, it's a vector of factors, and the same thing will be given by type of. Okay, so this you can see here, it's a of type factor, but internally it's represented as an integer. Okay, if we have a lot of factors, we cannot remember them all. Yes, we don't need to remember. So how can we query for a factor of specific string value in column 5? So all the operations that you can do, so I can do this. Let's say SP 20 30 is equal to okay, I can do that. So I am comparing, oh, that's a string value. Did I type it correctly? Virginica. Oh, no. Okay, probably it's taking as a string value. So your question is, how can we query the factor of a specific string value in column 5? So you want to select all the species with Virginica or something like that, right? Is that your question? Do you want to come on air if you think that's easier? Okay. Okay, go ahead, Sanjeev. Sanjeev, we cannot hear you. I think you muted. Hello? Oh, okay. Issues with your mic. Yeah, sure. Take your time. Okay, so we can index into the array according to by giving these things, and on top of this, we can even. So we already saw this structure of iris. We can even select different columns. So let's say I want to select the first column. Okay, what do? I'll say iris. I will not give anything for the rows. If I don't say anything, it will take all the rows or all the columns. Then I can say that. So I am taking the first column across all the rows. That's my list of values. Okay. The same thing I can achieve by saying like this: iris dollar, the actual name of the attribute, sepal length. Okay. So this is another way of indexing into the data frame. Since data frame is kind of consisting of multiple columns with some names associated with them, you are able to get the individual values by using this dollar command. Okay, so after dollar, you can provide the column name, and it will simply get the entire column. So similarly, I can say iris dollar species. Oops. Okay, that's a capital S. Okay, so that shows that R is actually case sensitive. So when I say small s, it did not find any column with species with small s, and therefore it returned me a null. But if I give the right case, I got the list of values associated with that particular column. Okay, that's another way to select a column. Okay, so these are all different ways of selecting columns. Now we skipped one function here called sorting. So here it's constructing a small data frame from the individual vectors. Okay, so let's construct something like that. So let's say D is equal to data frame of C of 1, 2, 3, 4 and C of 5, 6, 7, 8. Okay. Oops, I did not give any names. Actually, let's see what it gives. So I can say str of D. Okay. I have 4 observations with 2 variables. Okay. And so by default, it just gave this as the name of the column. I did not provide anything, but instead I can provide a column name by simply saying col1 is equal to that, or actually let's say x is equal to that and y is equal to that. Okay. Now if I say call names of D, I'll get x and y. Okay. These are the 2 columns that I have in my data frame. Now if I simply say D, I will get the entire data set, 4 columns, 4 rows with 2 columns, and first column is named X, second column is named Y. So now I can refer to it as $X, I get the first column, $Y, I get the second column. Or similarly, I can do that for the first column, I can do this for the second column. Okay, that's the very basic indexing into the data frame. Now you can actually sort across the values as well. Okay, I think we constructed already sorted order. So let's change it just so that we can understand the sorting in order. Let's take the same example. 7, 19, 2, and 3. Okay, if you want. Okay, that's your data frame with 2 columns X and Y and bunch of values, right? So you can sort on X using the function called order. Okay, so there is a function called order which essentially does ordering of permutation. Order returns, okay, we'll get to the help in a bit. So what does order give you? So I can say order of a particular column from my data frame. So I can say order of $X. That means I'm sorting the values of the X column. Okay, it says 1, 4, 2, 3. Actually, let's sort Y. Okay, it says 3, 4, 1, 2. Whereas my values are 7, 19, 2, and 2, right? So this is actually the order gives you the indexes, not the sorted values, but the indexes. So if you take the third column, the third value, fourth value, first value, second value in that order, then you get a sorted values. Okay, what is my third value? 2. Fourth value is 2 again, and the first value is 7, second value is 19. Okay, as you can see, this is exactly the sorted order. So the order gives you the positions in which if you place those values, you get a sorted order. Okay. Now, obviously, if I want the values to be sorted, then I can provide this as an input to my indexing expression. Okay. So in the sense of like the order of $Y, comma. Okay. So essentially, you sorted all the rows according to the values of Y. Okay, that's exactly what that is doing. So order gives me the list of locations, list of indices, and you are providing that indices as an input to my indexing expression. Okay, so I'm selecting the third row, fourth row, first row, second row in that order, and therefore I get the sorted output according to Y. Similarly, I can sort it based on X as well. Okay. Is that clear? Okay. I'll get to your question, Sanjeev, in a bit. In case of a data frame which has high number of columns, how to retrieve the column names. So that's why we saw this function called str, which will give me the list of column names. Or I can say call names of D. Oops, call names of D, which will give me the list of column names. Okay. And we can also sort based on multiple columns. We essentially give a list of column names. So here in the help file, you can see order takes first of all the data that you want to sort, okay, and whether you want to sort in decreasing order or increasing order. So if you do not specify anything, this decreasing will get false as value. That means you want to sort in an increasing order, okay, and I can specify a different sorting method as well if I want to. Yeah, there are a bunch of examples here. Okay, this one essentially constructing a matrix using rbind and then doing some ordering on top of that. We don't need to go into the details of that example, but essentially order gives you back the indices. Okay. How to change the sequence of the order? Yeah. Okay. So you see that, right? With the by providing this decreasing or increasing. Okay. So let's go back to Sanjeev's question. If we have dozens of categories, say like Setosa, and I want to get the factor for the string value, kind of like an index, then how can we query it? So one thing you can do, that's my other data type like table. Essentially, okay, I'll get to that question again when I tell you the tables. But so far, everything is fine. Data frame, indexing into data frame using the column names, column IDs, and then ordering based on a particular attribute or multiple attributes. Okay. Okay. So let's look at tables. So if I say table of the dollar species, is that the correct spelling? Oops. What is my spelling of species? Oh, D is no, I see. Okay, I can say iris dollar species. It essentially constructs a table, which is like a histogram. Okay. So in this particular case, we have exactly equal number of values to each of the category, and that's why we got 50, 50, 50. So table is like the histogram, but you can pass two attributes as well. That means two-way histogram. So if I have, let's say, D is equal to data frame of two attributes, x equal to C of A, comma B, comma C. Okay, those are my categories or string values. Then y is equal to P, Q, and Q. Okay, let's say this is my data frame with two columns, A, X, and Y, with these are the values. Now I can say table of $x. Okay, then obviously I have one value for each of this categories ABC. Similarly, I can say $y, P, and Q. Okay, that's the histogram of those values. And similarly, I can say $x, comma $y. Okay, which is like a contingency table. This is called a contingency table. So on one dimension, you have the x values, distinct values of x, and in the other dimension, there's the distinct values of y. Okay, and you get the mutual occurrences. How many times A and P occurred together? So there is exactly one time. And then how many times A and Q occurred? There's 0 times. B and P, 0. B and Q, 1. C and Q, 1. Okay, this is called a contingency table. Okay. Now, Sanjeev, to answer your question about indexing, essentially you can use this table as an index, right? The value at the first position is essentially, or the name at the first position is the category that is assigned value 1. And name that is at the second position is the value that is assigned 2, and so on. Okay. So, essentially the distinct values are ordered in the same order in which the internal integer values are assigned for that factor variable. Okay. Is that clear, Sanjeev? So we cannot really query a given factor. You can, extract rows and columns, but you typically never would query a particular factor value. You will see like get me all rows with a particular value, or get me all rows with a range of values. Queries like that, but you will never kind of search for a particular factor. Okay, the reason I'm asking is for Sanjeev suggests this particular function subset. So here you can provide the list, the object that you want to subset. Okay, yeah, let's take it again maybe at the end of the class. Okay, Sanjeev suggested this particular function. Maybe you can look at this function and see if that helps your question. Subset function. Okay. Okay, let's get back. So we sorted, we did all that. Now, a lot of times you will have your data spanning across multiple files and you want to join them, right? Typical use case in data warehouses and other places where your data is spanning across multiple tables and you want to combine them together or join them together and then create a bigger data set. And that's where this merge functionality is used. Okay, there is a function called merge, which is like a join in R. Okay, so in this particular example, we are creating a data frame with two columns, letter and A. Okay, this capital letters is a built-in variable, built-in object that gives you the list of all letters. Oops. Okay, list of all capital letters, and similarly list of all small letters. Okay, so this is a array, a built-in array that is given to you already. Okay, so here in this example we are taking the 8th letter until the 12th letter and assigning those values as this particular first column, and the second column is just a sequence of 1 to 5. So the resulting data frame would look like this, with two columns, letter and A, and then the values 8th letter to the 12th letter, which is HIJKL, and the list of values from 1 to 5. Okay, and similarly we are constructing another data frame here with some random sample of okay, so sample of 10 will give you just a sample size of 10. Okay, sample size, sample meaning just a random subset of values. Okay, so we are randomly selecting 10 values, 10 letters, and assigning that to the first column, and then another randomly selected uniform numbers and assigning them to the second column. So we get a data frame with two columns, letter and B. So the letter is essentially the randomly selected letters, and the second column is the uniform random numbers. Okay, so we constructed two data frames. Now let's say we want to join these two data frames, A and B, based on the letter. Okay, wherever H is there and H is here, so I want to join row number 1 in A with row number 8 in B. Okay, that's the functionality that we are looking for. So the way to do that is simply merge of A comma B. If you give A comma B, it automatically looks for the common attribute by name and then does the join based on that. Or you can provide the column name as well. So you can look at merge functionality. So here I have X and Y, two inputs, two data frames as my input, and then I can specify something called as B, by, okay, which is the list of column names on which your join has to be done. And by default, the this particular argument will get the value of the intersection between the names of X and Y. Okay, whatever is the column common attribute name between the two data frames, that will be used as a joining attribute. If there are multiple of them, all of them will be used as a joining predicate. Okay, so we can construct that example. Okay, so let's say A equal to data frame. Let's say X equal to letter of 8 to 12. And Y is equal to a sequence of 5 values, letters. Okay, that's my A. And then similarly I have B is equal to data frame, some randomly selected values. So let's say letters of sample of 10. Okay, and we'll look at sample later, but for now just assume that it's this entire expression is selecting some randomly 10 letters. Okay, essentially sample of 10 will give you 10 random values. Okay, similarly our uniform of 10 will give you 10 uniformly distributed numbers. Okay, that's my B. Oops, I forgot to give the column name to it. So let's say Z and Y or X. Okay, so A is this, B is that. Now, if I simply say merge of A comma B, we are merging essentially table A and B where A dot X is equal to B dot X. That's how the SQL query would look like, right? So this is a equi-join, right? That means whenever there is a match, you pick up the value. If there is no match, you don't pick up that value, either from A or from B. But sometimes you want to do outer joins as well, right? Left outer join and right outer join. Okay, so that's when you give these things, all equal to false. I mean all dot X and all dot Y. If I say all, then that means it's a full outer join. So you pick up the values which are not matching from A as well as from B. Okay, if I say all dot X, okay, let's actually run it and see. So if I say merge of A comma B, all dot X is equal to all. Okay, so I'm saying I want to select all the values from X and I want to do the join between A and B. So it's like a left outer join in relational world. That means I want to select all the columns, all the values from the left input, which is A, and then whenever there's no match, it will give me NA. It's like a missing value, not applicable. Okay, so whenever there's a NA, it's like a missing value. So similarly, I can say all dot Y is equal to true. That means it's a right outer join. I want to select all the values from the right input. And whenever there is no match, I will get a NA again for the corresponding left side inputs. And similarly, I can just say all equal to true, which is a full outer join. So irrespective of the match, I will select all the columns from all the rows from all the inputs. Okay, is that clear? Equi-join, left outer join, right outer join, and full outer join. So Madhura says something, when compared to SQL, R not only performs statistical functions in many cases, the numerical algorithms used in aggregates and functions. I don't know how to read that sentence, but I hope you're saying compared to SQL, R not only does statistical functions, but also joins and aggregates like SQL does. Is that what you meant to say? Yes, that's true. But actually, I mean, there's overlap, right? Even in SQL, you can do some statistical functions. I can do sampling, I can do means, averages, and variance, and all those things. So there is some overlap between the two. But these kind of relational type of functions in R will be useful for you when you do some data pre-processing and some joining of different data sets and so on. Okay? Is that clear to everyone? Any questions? Okay, is everyone following? I take silence as all okay. Okay, so on LMS website, you will see the list of commands that we are trying out today, and then you can look at them and try them out by yourself if you would like. Okay, so this is all about merge functionalities. Yes, Sai Siva, the R scripts will also be posted on LMS. Devagna, this PPT is already there in LMS. So, I mean, in any class, whatever information that we will see in the class, whether it's in terms of PPTs or scripts or some other examples, or the data sets, everything will be available on LMS after the class. Some of the information will be there already, but some extra information, if I have to show something, I'll put it on LMS at the end of the class. Okay, so bottom line is whatever you see in the class will be on LMS. Okay, so just to summarize our merge functionality. So just like joins in relational world, we have equi-joins, which is like merge of A comma B. That means you select rows from both A and B only if there is a match. Okay, only if there is a match on the common attribute. And when I say all equal to true, that means I want to select all the rows from A as well as all the rows from B, irrespective of whether there exists a match or not. If there is no match, obviously you will get correspondingly null values, right? For example, in our case, so there's A, there's B, right? If I look at K, letter K, there's no letter K in data frame B. So there's no match for it. So obviously, if I want to pick up that row, the corresponding value for Z is not applicable, right? We don't know the value of Z because there's no K here. And that's why you will get NA. Okay, whenever you want to pick up a row, but there is no match, you will get the corresponding values to be NA. And when I say all is equal to true, that means I want to pick up all the rows from both the inputs. So that's why you will see some NAs on the right side as well as some NAs on the left side. Okay, so this is equivalent to a full outer join in the relational world. And similarly, there is a left outer join and right outer join, which is specified by all.x and all.y. Okay, all.x meaning you are selecting all the rows from the left input, and all.y means you are selecting all the rows from the right input. Okay, is that clear, Partha? Okay, great. So we already looked at this. How do we subscripts? How do we subscript into arrays and vectors and matrices? So when I say y of 3, I am essentially getting the third element in the array. And when I say 3:7, I am getting third, fourth, fifth, sixth, and seventh element. Okay. And I can randomly select whatever indices that I want. Okay. And more importantly, this one, -1 is essentially you are removing that particular entry and selecting all the others. So it's like an exclusion. So whatever you give here are like inclusion, right? When you say 3, I want to include third element in my output. When I say 3:7, that means I want to include third, fifth, fourth, fifth, sixth, seventh elements into my output. Whereas minus will do the opposite. You want to exclude that in your output. That's like a easy way of saying select everything except a particular column. Okay. So let's take iris again. So we have all the 5 columns. Okay. If I want to select all rows except the 5th column, I can say that. Okay. Iris of all rows and -5. Okay. That means I want to select all the columns except the 5th column. Okay. And similarly, you can do that on vectors as well. So I can say vec is equal to 1 to 10. Okay. That's my vector. And I can say vec of -5. So I remove the 5th element and select all the other elements. And if I say -1, I am removing the 1st element and selecting all the others. And similarly, if I want to just select remove the last element, I can say length of vec. Okay, it removes the last element and select all the others. Okay, this is a way to exclude certain columns or entries in your output. Okay, and so we looked at subscripts using column names, using indices, and using negative indices for exclusion. And on top of that, you can also provide logical values as the predicate. Okay, so here I want to select all the values of y which are greater than 6. Okay, actually let's take this. I have my vector of 1 to 10. If I say simply vector greater than 6, okay, that means it will give me a Boolean vector of true or false. Okay, and it will be true whenever the corresponding entry is greater than 6. Okay, so essentially you are applying this particular conditional greater than 6 on every element in vector and then returning true or false from each of that comparisons. So similarly, if I say vec less than 3, I'll get first 2 entries as true and rest of them as false. Okay, that's clear, right? It's essentially applying this particular conditional on every element of the vector. And I can pass on this true false vector into a predicate as well. So if I say vec of vec less than 3, then that means I'm selecting all the values which are less than 3, which is 1 and 2. Okay, so if I'm vec of vec less than 3 will give me true, true, false, 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 and then I can pass all of this into my vector as an index. So it will select only the guys with the true value. Okay, like, I mean, we can even take a simpler example. Vec is equal to 1 sequence of 10, 40, 10. Okay, so I have vec of 4 values. I can say vec, and let's say I create a Boolean array, BARR is equal to C of true, false, true, and false. Okay, that's my Boolean array. All we are saying now is I can index using these Boolean arrays as well. So I can say vec of B array. Then I get all the elements wherever there is true. Okay, I have first element is true and the third element is true. So I'm selecting the first element and the third element from vector. Okay, and that's why here we are able to get all the elements whose value is less than 3 using this particular expression. Okay, that's clear. Okay, and similarly, you can provide any expression here, not just a simple less than, greater than, or equal to. You can provide any thing. So here we are saying select all the elements of y which are not multiples of 3. Okay, and this percentage is an operation for doing modulo. Okay, so whenever there is modulo of a particular element with 3 is not equal to 0, you want to select that value. So in our case, if I say vector percentage 3, oh, my vector is so small now. So I'm essentially doing a modulo with each of my 10, 20, 30, 40 modulo 3, and this is the output that I get 1, 2, 0, 1. Okay, and I want to select all the elements. So if I say vector percent 3 is not equal to 0, then I get wherever it is a modulo equal to 0, I get a false, and modulo is not 0, I get a true. Okay, now I can pass this Boolean array into vector itself. Okay, vector of that particular Boolean array. So I'm selecting all the elements from vector wherever this entire expression results in true value. Okay, so that means I get the first value, second value, and the fourth value. Okay, okay, that's just an additional way of indexing into your arrays. We can do the same thing for data frames as well. Okay, all this indexing applies to data frames, matrices, vectors, and so on. Any questions, guys? So Sudhir, do we have a concept of eigenvalues and eigenvector computation using R? Yes, we do. It's totally kind of not in the current subject, but yes, we can compute eigen. Actually, there is a function called eigen to compute eigenvectors. Okay. So yeah, this is doing even more examples of indexing. So you can even construct a 3-dimensional array. So far we've seen only 2-dimensional matrices, but we can also construct 3-dimensional matrices with using this array function. Okay, so here I'm taking 1:30, so that means all the values from 1 to 30, and I'm arranging them in this particular dimension. 5 rows, 3 columns, and then 2 in the z dimension. So this is a dimension 1, x dimension, y dimension, and the z dimension. Okay, that's how I'm arranging it. So in this particular class, we don't really deal with multi-dimensional arrays, but okay. But yeah, if you need them, you can always construct multi-dimensional arrays as well, and accordingly index into it. So far we looked at indexing expression with 2 dimensions in it. But if the data itself is multi-dimensional, then your indexing expression will also contain multiple expressions using commas, right? So in this particular case, if I create array 3D is equal to array of 1:30, C of 5, 3, 2, then my array 3D is essentially it's like two-dimensional matrices stitched together in the 3rd dimension, right? So this is my first matrix, and this is my second matrix. They are stitched together in the z dimension, and that's why you will see here comma 1, comma 2. Okay, so this is a value in the third dimension. Now, if I want to say array 3D of 1, 3, okay, 2, 3, 1. Okay, I can do that. Essentially, I am selecting the second row, third column in the first slice of the third dimension. Okay, second row, third column, and in the first slice of the dimension, z dimension. So it's a value 12. So if I say 2, 3, 2, then I get second row, third column, and in the second slice of the z dimension, which is second slice is this one, and the value is 27. Right? So you can also create multi-dimensional matrices and index into them using this type. And obviously, if I simply say that, it will give me an error because it's a 3-dimensional array, but we are only providing 2 indexing expressions into it. And that's why it's complaining, saying incorrect number of dimensions. Okay, this is just some more examples of indexing into the arrays. Do we have any questions before I cover the last data type called list? Okay. So list is like a parent data type. Let's actually take another example. I'll again put this up in the LMS as well. Okay, so list is like a parent of data frame actually. Okay, in the object hierarchy or the class hierarchy, data frame is a subclass of list. And at high level, list is an object containing an ordered collection of objects. Okay, it's a complex object where individual entry in that particular collection or in that particular list is called as a component. So list is a ordered collection of components. Okay, and there are multiple ways of accessing those components. I can say list $component name, which is exactly like we addressed a particular column in the data frame, right? And you can see the relation why we are able to do that. Because data frame is a subclass of list. Whatever that is applicable on list are also applicable on the data frame. So list is a collection of components with an order defined among them. And when I say list $component, I can extract that particular object with that component. Or there is also other way of accessing that component by specifying 2 open parentheses, not parentheses, 2 open square brackets. Okay, I can say component name here or component position. Let's take a look at the example. So let's construct this list. Okay, let's actually copy paste this for speed. Okay, so if I say class of L, it is a list, and how many elements are there? I can say length of L. I get 4. So that means this list contains 4 components. Okay, this is the first component, second component, third component, and fourth component. And each of that component has a name associated with it. Those names are name, wife, number of children, and children ages. Okay, and I can address each of this component via $name. That will give me the component with name. And similarly, I can say $wife. I'll get a component whose name is wife, which is equal to Mary. And similarly, $number of children, which is again a component with name num children, so which is value 3. Okay, So that's the way you access individual components in the list. This is exactly like the way we access different columns in the data frame. But on top of this, if I just do LF1, okay, that means I'm just getting the first component, okay. And what did we say? The component has a name and the value, and that's why you are getting the name and the value. So if I say LF2, I get the second component, which has a name and a value. And similarly, if I say 4, I have the fourth component, which has a name and a value. So if I give you one open bracket to the list, I get the individual components. And if I want to get the value within that component, I have to provide two open brackets. Okay. So you see the difference between L open and 1 and L 2 opens and 1. Actually, let's take this example. So L of 2 is essentially the second component, and that component has both the name as well as the value. Okay, that's why you will see name and the value here. Whereas if I say 2 open brackets, then I'm getting the second component and the value of the second component, which is Mary. Okay, is that clear? The difference between extracting a component versus extracting the value of the component. Okay, exactly, Sanjay, that's right. And so instead of these indices, I can even provide names to it. So I can say L open wife. Okay, instead of just the index value, I can provide the name as well if I want to. So I'm getting the component associated with the name wife, which is my second component. And then by putting another bracket, I'm getting the value of that component. Okay. So similarly, if I say L open 4, I will get the value of the fourth component. Okay. And what is that value? Which is again a complex type of an array. Is that clear? Yes, names have to be unique across the list. That's true. Okay, now can somebody tell me how do I get the age of the second child? Okay, if I want to extract the age of the second child, what expression do I need to write? Can anybody guess? Okay, let me go step by step again. Yes, Sanjay, you got it right. So this is my L. We saw that L of 4 will be the fourth component, which has both the name and the value. Now, if I want to get the value of the component, I would open two brackets, okay, which is again a complex type, which is an array. Now, how do I get the second element of that array? I'll simply specify 2 like this, right, of a particular vector. And what is my vector? This entire thing is my vector. Oops. Okay, this is entire vector, and I'm selecting second value in that vector. So that would be the age of the second child, which is similar to, we already did something like this, right? Vec of 2, which will give me the second value out of this vector. And it just happened that this vector is happened to be this big expression. So therefore, this will give me the value of the fourth component, which is a vector, and then I'm selecting the second value in that particular vector, which is 7. Okay. Oh, did I say Sanjeev? I meant to say Sanjay. Sanjay got the right answer. Yes, I don't think this one will work. You can see. Okay. Because first of all, you cannot give so many commas. If I have 3 commas, that means it's a 4-dimensional data, right? Whereas it's not a 4-dimensional data. It's just that a list containing more complex objects within that list. Okay, so Sanjeev, that doesn't work. Now, let's look at the full example now. Okay, so this is our list. Length of list is 4, obviously. When I say L of 1, I get the first component, which is like a list with one component within it. And L of 2 is a list, again, with one component. And that's why it has the name as well as the value. Now, this is accessing the individual components. If I want to access individual component values, then I have to put two open brackets with either the index or with the name. Or in even simpler one is just simply putting a dollar value. Okay. So we saw L $name is equal to Fred, L $wife is equal to Mary, which is same as saying L open 2. Okay. So similarly, when I say L number of children, I get 3, L child ages, I get 479, which is again a complex value. And therefore, we can further index into that using this complicated expression. So as you can see here, using dollar symbols is much more simpler. Okay. So when I say L child ages, I get the complete list of all the child ages. And then I'm getting the second value out of that, which is a 7, which is the age of my second child. Okay, is that clear? The list? Any questions here? So again, all this is very basic introduction of different data types. You have to kind of work with them, play with it a little bit in order to familiarize yourself. Since R is open source, go ahead, install it, and play with the examples that we have seen in the class. Okay. So only when you start using it, that's when you can appreciate and you can understand all the concepts related to these data types. Okay, I think we'll stop here since we are at the top of the hour already. If you have any questions, shoot, I'll be here. So Sanjeev has a question. I have a data file with 9 columns and over 1 million rows. How can I get R to apply my small script to it? Say for creating a correlation matrix. So do you want to create all pair combination, all 9 choose 2 correlations? Okay, so there is actually a function called apply, which we'll see in the later classes. There's a function called apply, which you can use. Okay, but we'll get there. we'll see an example of that in the later classes. Yes, there are many other data sets other than Iris. Actually, there's a package called datasets. That should be there automatically, and that will list all the datasets. Like if you do this. Okay. So it opened this. This is all the list of datasets that are available already in your R instance. Okay. So you can look at them, you can play with them if you want. Each of which have different type of attributes. Some will have categorical, some will have mixed attributes, some will have only numerical attributes, and so on. Okay, I wanted to show you I/O as well, reading and writing data, which is read.table and read.csv, and similarly write table and write CSV. But maybe we can look at them in the beginning of the next class. Or if you guys are okay, I can continue and show those basic examples. Should we continue? Okay, so let me quickly show reading and writing. So let's say we have this Iris data set, right? And let's say I want to write that Iris data set onto disk. So I can say write.csv, and I'll say Iris. Actually, let's look at the help file, and as we see it, we can. Okay, write.table. Not surprisingly, it will take the data object with that you want to write, and the file name wherever you want to write that data, and bunch of other options. Like quote equal to true means if you have a string attribute, should it be quoted or not? Should I put quotes around it? And what is a separator? Okay, between different values in the row, what separator should I use? Is it a space or a comma or what? And then what is the end of line? So these are all default values to be our intuitively they are set to /n and so on. But if you want to change, you can change. And you can specify row names associated with each of the row that you are writing, and similarly column names. Okay, so let's just write something and see. Write.csv. I'm writing my Iris data set, and the file location is, let's say, my iris.csv. And this my iris.csv will be created in the current working directory. Okay, and we know what is our current working directory, right? Which is getwd. Okay, it's in C Edureka. So whatever I write will go into that folder. Okay, my iris.csv. I will say separator is equal to a comma. Actually, since it's CSV, by default it's a comma, so you don't really need to specify. So that's all you need. Okay. Now if I go to my file system, this is my iris.csv. Okay. So by default, it created the row names as well, which is just the index, row index, and all my columns with the corresponding values. Okay. And if I don't want my row names, I can simply say row.names is equal to false. Let me close this, otherwise we'll get a permission error. Okay, I wrote it. I go back. I look at it. Now my row IDs are gone. I just have the data. Okay. Now I can. So that's how you write the data into HDFS. So here I'm not really writing it into Excel. It's just a CSV file, and on my operating system, the default viewer for CSV is Excel. So that's why it opened Excel file. But if I want it in a text editor, I can open it in a text editor. Okay, this is how I get it in the text editor. All I'm doing is I'm writing a CSV file. It doesn't matter how you read that CSV file outside R. Okay, so we just wrote a CSV file. We can read it back into our, so again, let's say my iris is equal to read.csv, and you simply give my iris.csv as the file name. Okay, now if you see class of my iris, it's a data frame. Again, I can do all my commands on that. Okay, so it's as simple as that. If we can write CSV and read CSV, and whenever you read CSV, the return value will be a data frame. Okay, according to the columns that are provided in my input file. These are my columns. If you do not have a header file, by default, it will give you a default column name, V1, V2, V3, or X1, X2, X3, some default column names. Okay, that's how you read and write data to your local disk. And similarly, if you want extra other formats, if you want to get data from other systems like Weka or SAS, then you use package called the library, the foreign package that we initially installed, right? So that foreign package will have a lot of adapters that you can use to load and import and export data. So it supports Minitab, SAS, SPSS, Weka, and so on. Okay, this is just adapters for reading and writing several other formats if you would like to do that. And similarly, you can connect to a database as well. So there is a package called RODBC. So if you say install packages RODBC, it's installing that package. Now I can say library of RODBC, or I can, even without loading it, I can directly go here and look at my package. Okay, this is a package with which you can connect to a database, and you can see the help here. There will be some commands for connecting the database. There will be some function to disconnect from the database, and there will be some commands to read a particular table from database into your R instance as a data frame. And similarly, the way you export a data frame into a table on the backend. So there are all these functions that are available in this particular package. Okay. Shabarish, I think your question is answered, right? About writing R data into Excel. I'm just writing a CSV file, and it's just happened to be read as Excel. Okay. Can we now go to correlations of my iris? We'll get to that example, Sanjeev, which will create, basically we have to look at the apply function and then creating all possible combinations of the attribute columns. So we'll get there. And Sanjay, what's the difference between read.csv and read.table? So in read.csv, the default delimiter, the delimiter is defaulted to be comma, and read.table is much more general. You can specify your own delimiter, and therefore it's a little more general than read.csv. So you can treat read.csv as a specialization of read.table. Okay, how to write it into a specific directory? I can when I say write, I can give a full path here. I can say data science / my iris. That means it will go into this data science folder. Okay, so I can give a complete path there. Will ODBC work in Mac? I frankly never tried, but it should work. I'm guessing it should work. I never tried it on Mac. Okay, what I see is that the current art design is compromised between functional and imperative, and therefore gives more space for creativity in its own. Exactly. As far as I know, R is the first HTML5 IDE that people actually like and use over fully native alternatives. In case of less memory on the computer, RStudio can run on the server, so it's easy to set up an EC2 instance to run it. I see that it has a powerful debugger too. Excellent, Madhura. You capture a lot of positive points about R. Yes, as you observed, it's a combination of functional and imperative languages. And we'll see later in the context of apply, where you define a function on the go, which is in the style of functional languages. And yes, about RStudio, you can run it on as a server mode as well. That way you can run it on a server machine and then use it across all the clients. That's true. But still you are limited by the memory of the server machine. Not the client machine, but you are limited by the memory of the server machine. Okay. Okay, any other questions or comments? Okay, if no other questions, we can stop here. In the next class, we will start getting into the actual data science by looking at algorithms for clustering to begin with. Primarily, we'll start with k-means and some other examples on document clustering and so on. Okay, so first we'll cover clustering algorithms, and then we'll go to classification algorithms, and then subsequently we go to some recommendations and data mining algorithms. Okay. Oh yes, R definitely works on 64-bit machines. When you actually go to download R on the web page, you can download either a 32-bit version or a 62-bit version. I mean 32 or 64. I mean not as you download, but as you install it, you can choose which version to install. Okay. Okay. Bye, Sanjeev. Okay, so if no other questions, we can stop here, and please take a moment to submit the review. I got some comments from the previous class. As I told you, LMS will be updated with all the material that you see on the from the class, and I'll talk to Edureka team to see if assignments can be evaluated. I don't know if I have an answer to it, but I'll talk to them and see if assignments can be evaluated as well, as one of the person raised that concern. So do we have any assignments for what we learned so far? So whatever you, I mean, the quizzes cover some concepts that we covered so far. So that should be sufficient for now. And in terms of assignments, they're not really formal assignments so far. At least that's what I understand. But I can, I'll talk to the Edureka team and see how they would like to proceed in terms of assignments. Should we give a formal assignment at the end of every class, or are they more like homework exercises that you just try it on your own? Okay. Yes, Devagna, I'll make sure the quiz is corrected. Okay, so see you all next week, and yeah, have a good week, and please fill in the survey. Thank you. Okay, Madhura, if you have some questions and without taking the class time, is there a way to interact with you other than email? Unfortunately, no. The only way you can ask questions outside the class is through Edureka support team. They are actually very good at answering the questions. And whenever they cannot answer those questions, they'll forward those questions to the instructors. Okay. So Sanjeev, again, I am not really sure we can share our email IDs. I have no problem, but when the instructions that I got from Edureka team is that they would like to keep all the interactions through the support team. They want to give the interface as a support, and that's why they advertise it as 24/7 constant support, and in which they're very good at it, I have to admit. So I'll see if I can give the direct ID or not. Okay. Okay, great. I'll check it out. So Rajiv, about the yesterday's class, it was actually mainly some basics of big data, data science, and the type of tools that we are going to use. It's just to get the background and to get everyone on the same page. You can actually look at the video on the LMS website. I hope you are familiar with that. You can look at the complete lecture video on LMS, and that should kind of give you an idea about what all things that we discussed. Okay. Great. Any other questions, guys? Okay, and I'll upload all the material on LMS, and please try out on your own, and that's how you can pick up a new language, and through exploring you will use it. Okay, great. So we'll meet in the next class next week. Until then, bye-bye.